Oh, somebody grabbed the book, that's fine.
So you're videoing it now?
We're gonna start, yeah, we're gonna do this. Okay, so, should have one of these books here. This is when I first started teaching meteorology, these 18, 19 years ago. We had no textbook. And we had internet, except for one semester when the Great Plains was spamming the world. So they shut down the internet for one whole semester, and I was teaching meteorology at the time, and I had nothing to do it with. So the boss at the time, Mr. Horser, said, create one. So I went home and downloaded a bunch of stuff and brought it up here on a flash drive, and the lady who is now Miss Bunny, but whoever her predecessor was, she printed it up and bound it for me. This was our textbook for years. We don't use it much because we have the real textbook, and everybody loves textbooks, right? But this is good because what it is if you look in the book, it's stuff I've downloaded from the internet. A lot of the stuff is in the textbook also. But one of the things I can't really find very well, and the page numbering is kind of weird, but if you flip over to page, look at the top, it says page 12 of 34. It's going to look like this. 12 of 34. Now, this is, I created off the line years and years and years ago. But what this is we've talked about the fact that they publish 12 of 24. It's gonna be right in the ballpark right there. Okay, so what you do is, I already told the fact that the weather station we have that's not working, by the way, it used to work for years and years and years. But they've got hundreds of weather stations throughout the United States. There's in the Lawton area, you can find the one in Bishop Road, you can find the Lawton Public Airport, you can find Fort Sill, and there's probably 2 or 3 others out there. But there's weather stations. What they do is they take all this data and they send it to a national clearinghouse. Norman has got one for the Tornado Center in the United States. Mr. Wolf, kill the video, please. Kill the video.
Huh?
Thank you. Flip it down. Thank you. So Norman's got one. There is a Hurricane Tracking Center in Florida, but they got some national clearinghouses. But what they do is they give the data and they send it out to the weather places. And if you go over, and you can find one of these in the book, but if you flip over to page 16 of 34, you've got a map, sort of like what they do. This map is United States map, or part of the United States, and these little circles on there are surface weather symbols. It's a shorthand for meteorologists so they don't get a printout of everything that's happened. Like when we were doing the daily observations, and I pulled up the Weather Channel up here, and you wrote down the data. What they do is they have pictures that's just a flash of what's happening. Okay? And the picture always starts with wherever the map is located. They put a circle there, and when you blow up the circle, that's where they put the data. So looking at it, somebody who knows this stuff can interpret the data. They don't have to read it all. They can tell basically what's happening. Okay? A couple things you got to know about it as we go through here. So if you flip again, you should be on 12 of 34. The weather center is the weather symbol. Starts out with a circle. I already said that. Okay? And in the upper left-hand corner of this weather symbol is the temperature in degrees Fahrenheit. Okay, because this is the United States, we're number 1, we do weird, nobody else does Fahrenheit, but we do. So degrees Fahrenheit. I'm making these numbers up, so don't even look for me anymore. So let's say yesterday's temperature got up to 85. So whatever the temperature was when they created this weather symbol, upper left. Then down below, there's a chart over here. On page 15 of 34, and there's actually another one on 17 of 34. These are what type of precipitation is out in the world. Okay, if there's no precipitation, if it's not raining, snowing, or anything, you leave this area blank. There's nothing written there. But if it's raining, put a dot or whatever. And the boxes are because when you see the rain on here, it's because those are computers. Computers don't do circles, rounded edges very well in the old days, okay? So this is an older picture. So they would use little squares instead because round dots weren't very good. So you would do what type of precipitation it was. And if there's no precipitation, you just leave it blank. That's kind of weird. Okay. The bottom left-hand side of this weather pattern is called the dew point temperature. And this is kind of important, you know, because we've talked about dew point is when the temperature reaches the dew point temperature, that's when you get moisture coming out, when you get the clouds starting to form, when fog starts to form, when moisture gets out of the ground, stuff like that. You need to, and that means the atmosphere is 100% saturated. So the dew point temperature is normally going to be lower than the temperature, or the same temperature as the temperature. Again, making these numbers up. Okay. In the middle of the chart, the circle itself, and again, they got a breakdown over here. Sorry about all this, you get black. On page 17 of 34, what is the sky look like? Now, if there's no clouds, what you would do is you'd make a double circle. There's no clouds. If, on the other hand, there are clouds, this chart breaks it down. You look at it, okay? What does it look like? Clear, 1/8 of a sky, which is, you know, just less than a quarter. Scattered clouds, things like that. And there's a pattern cloud coverage right there. It tells you what to do. So again, you would decorate that box in that way. Now here's the one that everybody is going to get wrong. And it's not that you guys are dumb, you guys are very smart, but I've had problems with this. There is a little math involved in this. And yes, science has math. In fact, if there's no math, it's not really science. Okay? I like that. I just found a cartoon. I wish I'd printed it. Shows, you know, the Trojan horse. And the Trojan horse is labeled as physics. Everybody loves physics. You just blow things up, bump things around. But inside the Trojan horse being snuck into Troy, it says math. And then you got a picture of one of the Trojans standing out there saying, fun science. But you don't realize science has got math. So you need to know math. It's something you got to know. So, what are we talking about? On the barometer. Our barometer is inches of mercury. Again, inches is a standard measurement. Nobody else in the world except one other country uses that. So you can do millimeters of mercury, but they really don't use that. They also have pascals, millipascals, or what they've done is pascals and millipascals are basically the same as bars and millibars. Can be shortened as millibars, which is, there's 1,000 millibars per bar. 1 bar is sea level pressure, about 30 inches of mercury. So what to do is you have to convert it. So making the numbers up. Let's say our barometer is 30 inches of mercury. You take the 30 inches of mercury and you multiply it times 33.86. I've got calculators, guys. And I got 1015.8. This is millibars. Now, when you are writing the pressure on your circle, it's going to go up here in the upper right-hand corner. but you don't write the whole number. And it explains what you're writing here. You write the last 3 digits but you leave the decimal out. So for this pressure right here, I would write 158. Again, it explains it in the book, okay? So that's the pressure. Then you have what's called the wind barbs. Again, there's 2 things, or actually 3 things to go with this. And again, go over to 17 out of 34, you can see. First is, which direction is the wind coming from? If it's coming from the south on a map, you draw a line up this way. If it's coming from the east, you draw it this way. Where's the wind coming from? That's the direction the flag is pointing. That's where it's coming from. Number next, how fast is it going? Now, if you read the fine print of this, they use the measurement called knots. Knots is a nautical term. What they did is 100, 200, 300, however long ago, they took a rope and they put knots in the rope. And what they would do is they'd have some guy at the front of the boat drop the rope off and hold the rope. And they would count how a spot on the boat, how many knots did we go by? And that's a way to estimate speed. Well, knots do not really have an equivalent on ground. But when they started flying airplanes, they used knots for aeronautics, for flying. 1 knot is equal to about 1.15 miles per hour, about. But since that's not really much, we're not changing, we're not calculating. So whenever we do the little quiz here in about 15 minutes, and it's not a hard quiz, but whenever we do the little quiz here in about 15 minutes, if it says 10 miles an hour, just look on there for 10 knots, okay? Don't try to convert. Just whatever the miles per hour is, use the knots, okay? So let's say the wind is blowing at 10 miles an hour. So you can look on this chart, 10 miles an hour falls between 8 and 12. It's 1 long flag. So what I would do is 1 long flag, 10 miles an hour. Okay. And that basically is all we're looking for. So on your little handout there they gave you,
On the piece of paper with the
the
circle?
piece of paper, this is just a practice.
Oh. You want us to do that?
I'm gonna do this, you're gonna look at the book and interpret it. You're gonna copy this, then you're gonna write down what your interpretation is. The quiz is gonna be, I've got one for you, I'm gonna give you and you're gonna create it.
That don't make sense to me. It just says surface weather symbol.
Yes,
So that's the surface weather symbol that you're making right now?
I'm making one up.
You're making it up.
I'm making one up.
How do we know which one to make?
Draw that. What I got, draw this right here, what you got.